Course 3, Lesson 88 is all about proportional relationships versus non-proportional relationships. So, your goal is to be able to solve 3 important ideas about proportional relationships determined from its graph, table, or equation if it's proportional, and determine whether proportional thinking can be used to solve word problems. So first, let's look at some important things about our proportional relationships. First, we also know that they are named direct variation. We can show it with an equation that's y equals kx, which k is a constant. It's always linear. It always has a constant. That's our k in our equation, or our consistent slope that makes it linear. It's the same as direct variation, and it always goes through the origin. Also, in a proportional relationship, how many variables are there? Well, if we think about our equation, we know that we have y equals kx. Well, k is the constant. That's not really a variable. But y and x are variables. So, in a proportional relationship, we have 2 variables. Let's see if we can write today. Maybe. Having some trouble. All right, so in a proportional relationship, we have 2 variables. What does the graph look like for a proportional relationship? Well, on a graph, we are looking for 2 things. We are looking that it goes through the origin and that it's a straight line, whether that's a straight line up like this, or maybe it's down like this, but regardless, it's a straight line through the origin. If one variable is 0, what is the other variable? Well, what they're saying is, let's make a table, x and y. If x is 0, and we plug it into our equation, y equals kx, that means that y equals k times 0, so y is 0. So if one variable is 0, the other variable is 0. That's what makes it go through the origin. So regardless, if y is 0, if x is 0, we know that the other variable is 0. Okay, let's look at these equations. Which equation is an example of proportionality? Okay, a proportional relationship. D equals 30t. Well, we look in this and we say, all right, do we have 2 variables? Yes, we do, d and t. All right, we look and we say, do we have a constant? And we can say, yes, we do. 30 is that constant. Okay, next we look and we say, would it go through the origin? So we plug in some numbers for d and t. We say if d is 0, what is t? So 0 equals 30 times t, which means the only way that we can get 0 on that left side is if we have 30 times 0. So t would have to be 0. Okay, so would this be a straight line on a graph? And we would say yes, because if we continue this table and we say d is, I should have had these flipped. Let's flip them now so that we're not confused. Okay, so t is actually our independent variable and d is our dependent, so I should have had it like this, t and d. We have 0, 0. If t is 1, we plug it in, 30 times 1, d is then 30. If t is 2, d is 60, 3, 90, and so on. What this tells me is that as I go up 1 for t, I go up 30 for d, which means yes, this is a consistent line, a consistent positive line. And our constant, we can say, is y divided by x is 30. You see 30 divided by 1, 60 divided by 2, 90 divided by 3, 120 divided by 4. Those are all consistently 30. So we do have a proportional relationship. So we say d equals 30t. Yes, This is proportional. How about a equals s squared? It has two variables. That would work. Let's see if it goes through the origin. We say s is our independent, a is our dependent. So if 0, okay, 0 for s, a would be 0. Okay, well that fits. It goes through the origin. Let's see if it's a straight line. If I say side length is 1, then area is 1. We're on a good roll. Side length is 2, area is 4. Side length is 3, area is 9. 4, 16. The question is this a consistent ratio? 1 divided by 1 is 1. 4 divided by 2 is 2. 9 divided by 3 is 3. You can already see that we are having some problems because these numbers that we get out here, 1, 2, 3, and 4, they are not the same. If this were proportional, we would see that all of these numbers equal the same thing, either 1, 1, 1, 1, or 2, 2, 2, 2. They would all be the same. So no, a equals s squared is not a proportional relationship, because if we were to graph it, we would actually see that it would curve like this. It's a curve. It's a quadratic, actually. And lastly, P equals 2L plus 2W. Is this proportional? Well, thing to remember, let's go through our list. Do we have two variables? Okay, so P is a variable, L is a variable, W is a variable. We actually have 3 variables, so no, this is not a proportional relationship. Okay, let's keep going. Let's look at some examples, some specific examples, and try them out. State whether each graph below depicts a proportional relationship. Justify your decision. So A, it's a straight line, but does it go through the origin? No. So A is not a proportional relationship. Cost of oranges, it's a straight line, goes through the origin? Yes, that is a proportional relationship. Area of a square, it goes through the origin, but unfortunately it is curved, so no, that is not a proportional relationship. More examples. Let's look at some tables and see if we can find those constants. Well, our constant, if we take our equation y equals kx, and we want to find our constant k, we would have to divide both sides by x. So to find our constant, I do y divided by x. So in this side length versus perimeter, side length is x, perimeter is y. Side length is x, area is y. So let's see if these are going to be constant. First, I'm going to do 8 divided by 2, 12 divided by 3, 16 divided by 4, and 20 divided by 5. That's just coming from my perimeter and side length for each. And as you notice, by dividing those, we get a constant of 4. So, are these proportional? Yes. Side length to perimeter is proportional. But let's look at our other one over here. Side length to area. Okay, let's try that, and I'll write it over to the left side. 4 divided by 2. 9 divided by 3. 16 divided by 4. 25 divided by 5. Well, I get 2, 3, 4, and 5, which you might think, oh, that's a nice pattern, but are my constants all the same? And we would have to say no. The constant is not the same, therefore, this is not a proportional relationship. Perimeter to side length? Yes. Side length to area? No, because we do not have a constant ratio. This one? Yes. We have all 4s. Okay, let's keep going. The heights of similar triangles are proportional to their bases. As a triangle is dilated, the base and height increase proportionally. Predict the height of the triangle when its base is 15. So your hint is find the constant of proportionality. Well, like we've done, we need to do y divided by x. So we do 3 divided by 2, 4.5 divided by 3, 6 divided by 4, and 7.5 divided by 5. And in each of these are each going to equal 1.5 all the way down. So my constant is 1.5. And how we can use this constant, we can see it actually in use in the table by saying 2 times 1.5 is 3. 3 times 1.5 is 4.5. 4 times 1.5 is 6, and 5 times 1.5 is 7.5. So if we know that my base is 15, extending this table to 15, I need to multiply by 1.5. And we end up seeing that that is 22.5 when you multiply it out. So if the base is 15, we would predict that the height is 22.5 based on that constant of proportionality. Let's look at some equations. State whether each equation is a proportional relationship. Justify your decision. So, C equals pi times D. So, we have two variables. Okay. Do we have a constant? Yes. Our constant is pi. Although it's a number that repeats forever and ever, it is constant. Is it in our equation y equals kx? Sure. Y is our circumference, d, our diameter, is x. Okay, so that works. Will it go through the origin? It will. Because if we have my diameter and my circumference, a diameter of 0 will give me a circumference of 0. So yes. C equals pi times diameter is a proportional relationship. Area equals pi r squared. We still have our constant. We have two variables. It would go through the origin, but the only thing is it doesn't really fit with y equals kx, because in our original, our x isn't squared. We just have a 1 for my equation, my exponent. So it doesn't really fit there. And if we were to continue and look at a table of our radius and area, we would have 0, 0, 1, 1, 2, 4, 3, 9, and so on. Our constant, okay, for between our independent and dependent variables is not constant. Okay, so that's a problem too. And if we were to graph this, it would be a curve, not a straight line. So no, area equals pi r squared is not a proportional relationship. And finally, y equals 2x plus 1. Well, it looks pretty good. It has two variables. We could maybe say 2 is our constant. But let's look at the table of this. If I have x and y, and I plug in x is 0. So I have 2 times 0 plus 1. Well, that means that y is 1. So does it go through the origin? No. Doesn't go through the origin. Okay, which is a big problem. And so we say no, that is not proportional. Moving right along. Which of these problems indicates proportional relationships? A. It takes 2 workers 5 hours to complete a job. How long would it take 4 hours to complete a job? Well, if we made a table of this, workers and hours, 2 workers is 5 hours. 4 workers, well, if we have 4 workers completing the same job, it's not going to take longer. It's not going to take 10 hours. It's going to take half the time because we have 2 times the workers. It's actually going to take 2.5 hours to do the job instead of 5. Because as we increase workers, it's going to take less time to complete a job. So, are those ratios the same? 5 divided by 2 and 2.5 divided by 4? No. So this is actually an indirect relationship or an inverse relationship. This is not proportional. All right. The shipping charge is $2 per item plus a $3 flat fee. It costs $13 to ship 5 items. What would it cost to ship 10 items? So, 5 items, that is 5 times 2, because $2 per item, plus 3, because we have that $3 flat fee. That's just a fee that's going to be on top regardless of how many items you ship. Okay, so that's for 5 items. For 10 items, we need to do 10 times $2 per item, plus 3. So we get 23. Now, the question is this a proportional relationship? Well, the best way to actually see it is in an equation, because we could write an equation to say my total cost is going to be 2 times each item plus a flat fee of $3. And thinking back to the last slide where we looked at our equations, that's not going to work because it's not going to go through the origin. That flat fee really messes it up. Lastly, each student read the same number of books. 30 students read 150 books. How many books were read by 60 students? So we already know that each student reads the same number of books. So let's figure out how many books they each read. So 30 students read 150. So I need to do 150 divided by 30. And we see that that is 5 books. So if 60 students read 5 books, I need to do 60 times 5, which is 300 books. And if we look at that in a table of number of students to books, if I have 30 students, I have 150. 60 students, I have 300. We see that that is a consistent, and we have a constant. If we have 0 students, we have 0 books. It goes through the origin. This is proportional because each student reads the same number of books. Okay. A few more. An equation in the form of y equals kx is a proportional relationship. As x changes by 1, y changes by a constant. Which of these equations indicates a proportional relationship? So once again, really quickly, y equals 5 plus x. The problem with this one, not going to go through the origin. It's actually going to go through 0, 5. So that one doesn't work. Perimeter equals 4s. We have a constant of 4. It's going to go through the origin. It's going to be a straight line. That one works. Area equals base times height. Unfortunately, this one has 3 variables. So that one's not going to work. Bottom question. The equation y equals kx is the same as y divided by k, x equals k, just like we said earlier. So if y divided by x equals 3, then which does not fit the relationship? 412. Well, if we put it in, we would say 12 is y divided by 4 is 3. 18 divided by 6 is 3. 3 divided by 9 is, not 3, it's 1/3. This one does not work. All the other ones do have that constant of 3. Which is not an example of a proportional relationship. Distance and time when driving at a constant speed. Well, that constant speed is our k, our constant. So that one will be proportional. Quantity and price when the unit price remains the same. Well, that unit price is our constant. So as the quantity increases, the price will go up consistently. That is proportional. Hours awake and hours asleep when the number of hours in a day remains the same. Well, if we increase the number of hours awake, that means that we can't sleep as long. So that's actually an indirect relationship that's not proportional. Okay? All right, last example. And at this point, you know that on a graph, the origin and a straight line is super important. So if it doesn't go through the origin, it's no good. If it's not a straight line, it's no good. But if it's both, if we have both through the origin and a straight line, that'll work. That is proportional. Well, I hope this was helpful for your studying and for homework.